Welcome back. We're in lesson 12 today, and we are going to review the linear equations. Linear equations are equations that are in the first degree and have a variable of x and y. We call them linear equations because all of the solutions, the ordered pairs for x and y that satisfy such an equation, is in a straight line when we graph them. And there are an infinite number of these ordered pairs of x and y that satisfy. So let's look at this first. Let me put this in black. I like black on that. Let's look at this problem here. We have y equals negative 2 over 3 x plus 2. This is our linear equation, and it is in what we call slope-intercept form. Slope-intercept form, I've gone over this just a few lessons ago, is y equals mx plus b. X is your x value on the line, or your point. Y is your point, or your y value on the line. So your x and your y together give you a location on a graph where you put a point, and that point is going to be on the line that corresponds with this linear equation. M is the slope of the line, and that is going to be the angle. The slope is basically the angle of the line and how it's drawn on the graph. And B represents your constant, which is also another word for the y-intercept point. But the constant is your constant rate of change against the slope when multiplied against x value, and that's how you determine the y. So you drop your x in. X is an independent value. It can be any point on the line that you want to choose, and y is solved by dropping in an x and then doing the calculation. So for instance, in this problem, if I put 0 in, then y would equal a positive 2. That is why B is the y-intercept, because we always do the y-intercept first to find that first point, because it's easy, because we can just eliminate this entirely by making x 0, which is the y-axis point, and then this is how far up or down we go on the y-axis. So it's an easy number to find to start with. It's a lot easier than, say, if we made y 0, because then we would have to solve all of this for x. So it's easier just to get rid of this entire thing here and find y. There's some logic to it. That's the reason why we do that. All right, so let's draw a little graph here. And we're going to plot these points on here. All right, so there's our y-axis and our x-axis. I'm going to label them for you just in case you forgot. And two of the pairs for this linear equation, we have negative 3 and positive 4. So we have negative 3 here, 1, 2, 3, 4 here. So that's a negative 3, positive 4, and we're going to label. You always label your points unless you're told not to. And then our other point is 3 and 0. So 1, 2, 3, and there's our other point. 0 is right here. On the line is the 0. And that's going to be 3 and 0. All right, and those are our points, two of the points on this line. I'm just making it line up a little bit better. All right, so the letter B in the general equation has been replaced with the number 2. This number is the y value when the x equals 0. So we can look right here and see that it crosses the y-axis, which is 0, at 2. It's 0 for the value of x. Let me rephrase that. x is 0 on the y-axis. So it's 0 and 2. So we could see that that proves true in our logic, that if we put 0 in for x, which is what we did here, then the base, this plus b, that's going to be our y-intercept point. So we can always just go on the y-axis and find this number and start our line, and then use our slope to draw any other points. Now this slope right here, this m, that's the m function, all we have to do to check it is look at our y value, which is on top, and our x value, which is on the bottom, and this is a -2. When it's a negative y, we sink, we go down. If it's a positive y, we go up. X is always to the right. X is never negative. X is always positive. Your negative is going to be in the numerator only. So if you have a negative sign out here, you push it up to the numerator. You never push it down to the denominator, okay? And if you think about it, what a fraction means, that this is the number of things in the set, and this really says that we have 2 less than we need to make a set of 3. So I'll let your brain wrap around that later. Okay, so anyway, this is the directions that we move. Negative is down, positive y is up, x is always to the right. Always, always, always. Now, another thing to note is that when you have a negative y, your line is always going to be downhill from left to right. It's always going to go this direction if it's a negative line. If you have a positive y, it's going to go up. It's going to drive uphill from left to right. That's always, always, always going to be the case. So we could look at, let me just draw a little mini graph over here. We could look at this graph over here, and not even knowing what the points are, if this were a line that were plotted on that graph, we could say that it is a positive slope. Without any other information, just looking at the line as a positive slope. If we were to draw this line without any other information, we could say that was a negative slope, because it goes, this one goes downhill, this one goes uphill. Up is positive, down is negative. Think about when you're up, you're happy, you're positive and upbeat. And when you're down, you're kind of sad, you're blue, you're in a negative space. If you remember those two connotations, that'll help you to remember the direction that of the line, depending on the positive or negativity of the slope. All right, moving on. What else do we have here? So what can we say about this line? We could say it has a negative slope, right? With a magnitude of 2/3. That's our slope. And that the y-intercept is 0 and 2. Right? And that's really all we could say about that line. Now, there are some other types of lines that we need to talk about and we need to bring to our memory. And those are horizontal and vertical lines. If we have a line, let's start it here and go all the way down here, and we know this line goes on and on forever, and this is 1, 2, 3, I can't count, 1, 2, 3, 4, 5, 6, 7, 8. This is -9, right? What is y? Y is all of the numbers on the y number line. It just goes, it's parallel to the y-axis. So y can be any number whatsoever. So what does that mean? It just means that x is equal to -9. Always, no matter what number y is. I mean, it could be 2. It could be, we could have a point here, -9, -2. If we have a point up here, that is, let's see, this is 4, 5, 6, 7. This point here is going to be -9, 7. So it doesn't matter what y is, x is always -9, and that's how you would write the equation of the line. That linear equation is x equals -9. So the same is true. Let me use a blue pen this time. Let me erase this. And then I'll use my blue pen. If you have a horizontal line, come on, Wheel of Death, quit thinking. All right. If you have a horizontal line, and let's see what this is at. 1, 2, 3, 4, 5, 6. This is 7. This is -7. What is the value of x? It's every value of x. What is the value of y? Well, in every value of x, y is equal to -7. So if we have a point here on the line, that's 2, it'd be 2, -7. If we have a point over here, that's -3, it would be -3, -7. It doesn't matter where on the line what the x value is. If it is a horizontal line, y is always equal to -7. Wherever this line is on the y-axis, if it is a horizontal line, it's y equals whatever that value is. Same thing for x. If it's a parallel to the y-axis, x is equal whatever this line happens to be on. Okay? All right. That being said, I'm going to clear the page. So pause and take notes if you need to. And I'm going to quickly draw out a graph for you with 3 lines on it for you to answer, or for you to evaluate. I should say, it's a better word. All right, here's one line. Here's the other line. Okay. Okay, so let me draw this is line A. All right, I'm going to use a different color for B. This is B, and I'm going to do yet another color. This is B. I'll do blue for C. And C is going to take a minute. So we have this, and then we have my dog wants out. He's just going to have to wait. All right. Let me see if I can draw this pretty good. All right, that's pretty close. All right, and this is line C. So we're going to give the equation for each line, A, B, and C. So I want you to pause, figure out the equation for each line, and then I'll come back and I'll give it to you. We'll see if we have the same answer for each one. So in the meantime, I'm actually going to make this screen a little bit bigger for you so you can see it better. Let me zoom in. All right, there we go. That should help a little bit. So you could see these lines a little bit better. All right, awesome. And this one is a little bit off. I just noticed that. This A. All right, it should be on this line right here. Not off of it. There we go. That's a lot better. All right, so pause. Give me the linear equation for line A, line B, and line C, and then come back, press play, and we'll see if you got the right answer. All right, you should have gotten all of those by now, so let's go over them and see what we have. All right, so for A, we have x. On the x-axis, it's -3, and it's the same. It's a parallel line to the y-axis, so that means that no matter what point you put on the line, x is always -3. So the linear equation for line A is x equals -3. Same thing for B, only it's on the y-axis. Anywhere on the line, y is going to be equal to -4. So y equals -4. That's going to be your answer for line B. Line C was just a little bit harder, but all you had to do was start with y equals, and then we look over here at the y-axis, and the intercept is 1, 2, +3. So we put in our +3 for B, and then we need to find our slope. And we always go from left to right, so we're going up 1 and 1, 2, 3 to the right. So that's up 1, so it's a positive number, and then over 3. And then we just put x next to that, and that is our linear equation for line C. All right, very, very easy. Once you get the hang of it, you can see it. You can go up 1 over 3, up 1 over 3. That's the slope of the line. Right there, up 1 over 3. And then you just put x next to it. That's all you do. And then 3 is the point at which it intercepts the y-axis. 1, 2, 3. And that's how you write the linear equation for line C. And that's all we have for lesson 12. And I'll see you in lesson 13.